Alright, if you're trying to find the zeros of a conic section and it does not intersect the x-axis, like this guy here, so this is the parabola x squared plus 1. Here, for quick reference, if it's just x squared, it hits here. And if we did something like this, you got zeros at 1 and -1 right there. There's 1 and 0, -1 and 0. So those are your zeros, 1, -1. They are real in this case. But in this case, it does not hit the x-axis. And also notably here, here, why can't I type? There we go. There's actually two zeros technically. There's the real zero and there's an imaginary zero. There's two zeros. And they're both a zero. And there's a reason for that that's going to become clear in just a second. So here, your imaginary zeros for this one are positive I and negative I. And the reason for that is that the cone that you cut conic sections from, the classical two-lobed cone that is used, is not the complete cone. It actually should be 6 lobes. So these are the angle at the apex of the cone should be 90 degrees, pi on 2 radians, and it comes out infinitely from the origin. The origin is where your the apex of each cone meets. Right, so you get 6 of them all meeting at that origin. Right, the classic model is that there's 2. There's one on top of another, and they have the same axis. Right, so here in the full one, you have 3 axes. It's 3-dimensional. There's 3 axes. There's a 2-lobed cone on one axis, a 2-lobed cone perpendicular to that, and another 2-lobed cone perpendicular to both of those. And they fill the space as completely as cones can. And so what's happening is here, when we cut a parabola out of this 6-lobed cone, the complete cone, what we get is we get the classic parabola that we're familiar with from the 2-lobed part that we're looking at. And then there's another parabola that we also get along with some hyperbole, or a hyperbola. And the axis of the cone that this other parabola is cut from is perpendicular. And that's why it gives us imaginary solutions. So if I select this, notice it hits at 1, it has zeros at 1 and -1. But because this is the axis of the cone that this is coming from is perpendicular, these are imaginary relative to our reference frame. Right? Our reference frame is actually the axis of the cone that we're focused on. Right? So like the principal branch, basically, which we get to choose. We get to choose which one is our principal branch. It's arbitrary. It's up to us. We get to choose which of these dimensions we're working in, which of these cones we're working with, right? So we get to decide which one of these, and the other two are imaginary relative to the one that we choose, right? So it's kind of weird because these do graph in the same plane as each other, but the solutions, the zeros that are here, aren't real relative to this. You'd think that they should be, but they're not, because what matters is between what's giving us the difference between real and imaginary here is the axis of our principal branch that we're looking at. There might be better words for this, but those are the ones that I'm coming up with. And then let's see. I think if I do this may be slightly wrong, but it'll at least illustrate the basic idea. This should be pretty close. That would be, so the hyperbola that, so there's one of your cones that we're cutting here, and we're cutting parallel to the side. So we get this this cut here, and that's going to be parallel to the side of one of the other cones. So we get this other parabola, and then those are going to be not parallel or perpendicular, or is going to be between. It might even be, yeah, it's probably going to be along, like parallel to the axis of this other cone here. So we get a hyperbola. I think I'm doing that right in my head. Anyway, the hyperbola isn't really what I wanted to show. I just want to show that there is actually 3 cones here. So here's this cone, there's this cone, and there's this cone. And notice that all of the, it doesn't actually matter if I go with the parabola or the hyperbola. Our solution is still negative and positive I, either way. That's where our zeros are, either way. Yeah, it's kind of coincidental in this case, I think, but it's okay. Anyway, yeah, so we can see this now with like the circles. So let's see, let me change this back to being compatible with this circle. Alright, so if I wanted, this does not hit the x-axis at all. So if we want the, yeah, it'll be this one. If we want, there's another hyperbola too that's corresponds to this circle. So if I want the imaginary zeros to this equation of the circle, it's going to fall here. Because if I try to graph this as a function, if I try to graph this as a function, what I'm going to get is I'm going to get this. And my imaginary zeros are going to be here. That's going to be this guy. So it's going to be that times I, negative 2.236, and positive 2.236 I. Those are going to be your imaginary zeros for this function right here. That's how hard that is. And it's because of the 6 cone instead of the 6-lobed cone. These ones are not, yeah, I don't think those ones count because you can't graph that as a function. Weirdly enough. Part of the problem is the notion of functions. The notion of functions doesn't really do very many things justice. It limits you significantly. So if we're working with the concept of functions, these are the 2 that you're limited to. The only 2 that you can get. So yeah, I thought that was interesting to note. Get rid of this. Get rid of this. It's real easy to see with the parabolas, because really you always, whenever you have a parabola, you just take the negative of it, take the opposite of it. They share that vertex, and this is why here there's 2 solutions, that there's 2 zeros that are just 0, because there's 2 vertices right there. there's the vertex of this one, and there's the vertex of this one at 0, 0. This is 0, I, 0. This is 0, the real 0. It's not like the true 0, but the real value, the 0 for the real axis, and this is the 0 for the imaginary axis. And they're both with respect to, intersecting with this axis here. And notably, what's happening here is these are both real. So you can tell that we're treating this strangely. Yeah, there's some weirdness. There's some weirdness going on, but like here, there's no imaginary zeros because the imaginary parabola, the parabola whose axis is perpendicular to the one that we're taking into account, because the red one is the one that we're taking into account primarily. The blue one, cut from the cone whose axis we're not taking into account, which is perpendicular to the one we are taking into account. This parabola does not cross the x-axis, so there's no imaginary solutions. This one touches the x-axis, so there is a real solution and an imaginary solution, and they're both 0. And here, the parabola we're taking into account does not cross the x-axis, but a perpendicular parabola to it does, so we get only the imaginary solutions that are its zeros.